Hi, I'm Kaitong, and this is my emath 3 assignment presentation on Euler method. So Euler method is a first-order numerical procedure used to approximate the solution of initial value problem using slope. And smaller step size makes the approximate more accurate. So given the equation, the initial value of y0 equals to 1 tells me that x0 equals to 0 and y0 equals to 1, which allows me to plot my first point. And in order to find the approximate value of y1, I will plot a point here under the curve, which allows me to form my slope. And the point above it on the curve will be the exact value of y1, which we will find in part C. So to derive the formula, we must first find the gradient of the tangent, which is also the slope here, which will be equals to rise over run equals to y1 minus y0 over x1 minus x0. Since our run is equals to our step size, I will sub in on the right side here equals to h, and since our gradient also equals to function of f bracket x0 and y0, I will sub in on the left side here, and since this function equals to dy dx, I will sub in again on the left to dy dx, and since dy dx is also equals to x squared plus 2 over y given by the equation, I will sub in again on the left, and the x and y value on the left will be x0 and y0 in this case, so I will make y1 the subject as we are finding the new value of y. I will sub in y, and then the new value of y will be n plus 1, then the original value of n will be y power n plus h times x n squared plus 2 over yn, and this will be my general solution. So for my Excel table, I'll have 3 columns, which is x, y, and dy dx. So from part A, I know that the initial value of x and y is 0 and 1, so I'll key in 0 and 1 in the first row of the value. And then for the x value, I'm using step size equals to 0.1, as smaller step size means the approximate value is more accurate. So I will put in a2 plus 0.1, and I will just drag it down like this until the value of x equals to 1, since we are finding the approximate value of y1. So in order to find the value of y, we will put in this equation, which we find in part A. So we'll put in the previous value of y plus 0.1 times the dy dx over here. So we'll key in and then we'll drag down, and then value here will be our approximate value of y1. And for dy dx, which is given in the equation, we will also key in the value here, and then we will just drag it down to find the dy dx of the value. To prove the accuracy of our approximate value of y1, we will solve the equation using separation of variables. So we'll separate the variables and integrate both sides, and as we integrate both sides, I will multiply the whole equation by 2 to make y the subject, and to find the value of c, I will sub in y0 equals to 1. So after subbing in the values, I'll get c equals to 1, and which gives me this formula of y squared equals to 2 over 3x cubed plus 4x plus 1. So in order to find the value of y, I'll square root the whole equation. And finally, to find the value of y1, I will simply sub in 1 into the x value, and then which gives me 2.380476. The Euler approximation of y1 is 2.402632, and the exact solution of y1 is equals to 2.380476. So the error percentage, I will use absolute bracket the approximation minus the exact value over the exact value times 100 to find the error percentage. Since the error percentage is 0.93, which is very low, it proves that a smaller step size makes the approximate value more accurate, and it also shows that Euler method is very effective to solve this equation.